thanks for coming. I'm very glad you're here in this beautiful city for this conference. My talk today is about OpenComponents micro frontends, or translated, my story about shipping front-end code to production at scale in a serverless world. So one slide to introduce myself. My name is Matteo. I'm originally from Italy, but I work and I live in London, UK. I am very passionate about coding. I'm actually a software engineer, so I mostly write code during my days. I am a very big passionate about open source and the DevOps movement, so I'm very glad to speak in a DevOps conference. What I love about DevOps is the idea of removing this artificial bridge between developers and operation or infrastructure engineers. And I work for a company called OpenTable, where I lead a team called Developer Experience. Our main duty is to create and maintain tools and infrastructure for our web platform. So, little agenda about today. We are going to talk about components and microservices, buzzwords that you have heard a lot of times during these years. I'm going to tell you a little bit about the OpenComponents platform, which is something that I'm going to explain what it is. And then I'm going to finish up a little bit with continuous delivery and front-end. So let's talk about components and microservices. And I want to start showing this beautiful piece of engineering. So why I decided to pick this picture that I really like. So I think one thing I like here is that we see a lot of components. So when you talk about components in software engineering, in general engineering, we talk about things that are not a new concept in engineering in general, right? So for example, when someone decided to design this car or the engine of this car, for sure, he started designing different components. Each component has specific interfaces, a lot of complexity hidden behind the scene, and interacts with other components, so it can be we can compose multiple components. One very good thing about components and engineering is we can create components in isolation, we can test them, and you can do a lot of beautiful things. For example, when we decide that we want to change something in a very complex system, we can change one component with another component that has the same interface. One other thing is when we have an issue, we can actually look at this component. We can debug it in isolation, and possibly we can replace it with a component that works better or just works if that component is broken. So when we talk about components in software engineering, we are very used to very simple, similar concepts. How many of you have heard about microservices? A lot. So microservices is all about that, right? So you code it, and you test it, and you run it, and that's beautiful. So that's beautiful. In my opinion, it's a very, very common topic in conferences. Have you ever heard about talks that explain how to break a monolith to little microservices? It's a very, very common topic, right? Because it's a very successful story. Many companies talk about that, how that was successful. And sometimes it's very important to explain that it's been very painful. It's something that a lot of companies try to do. And it takes years of technical and cultural challenges to actually get to a word that sometimes we are not sure if it was better than the one before. But you can clearly see some advantages. So my talk is not about that today. So what I want to talk about is something that I haven't heard so much in many conferences, and is a bit like the same ideas, but applied to front-end code. So I don't know how many of you write front-end code. Someone? Well, you possibly know that there are many, many similar problems that we have in the front-end world. When we work on big engineering teams on the back end, we learn that maybe having little microservices can help. We can have a different kind of infrastructure. We can evolve it in such a way that is more composable. But when we talk about front-end, we talk about a slightly different word, in my opinion. So nowadays, when we talk about development, we talk about very similar workflows. So a person possibly goes and logs in his computer, opens an editor, starts working with little libraries. So the code is modularized in many ways. We have libraries, we have components, we have multiple teams that can interact with continuous integration and can do pull requests. So if you look at that, it is not very different from how a backend engineer works. But when we talk about deploying, in the backend we learn about to deploy little microservices and to distribute ownership, in the front end, it almost looks like everybody still does a lot of work to bundle all together and to go to production with a single huge piece of monolith. So one of the core principles of microservices is you develop in isolation, you develop and little parts and you deploy them separately, so you have the ownership and you have the velocity of deploying little stuff, testing little stuff. On the front end, this is a challenge because we actually still deploy everything a little bit old school sometimes. So this talk is about me. I'm not going to teach you how to do this. I'm going to tell you the story about how I try to approach this in this company that I work for, which is called OpenTable, as I mentioned before. And I'm going to add a little piece here, which is how to do it at scale. And to show you the scale, I'm going to show you a couple of numbers. So we have something around 200 engineers in our organization. Around 50 work on this website. These 50 people are located in multiple offices inside the world. So, for example, San Francisco, Los Angeles, London, Mumbai. And this is actually very important because these people need to work in different time zones. When everybody sits in the same office, sometimes it's easy to collaborate. How you can collaborate when you have multiple people that actually have no overlaps in times of working hours like Mumbai or San Francisco. We have 20 teams. In our organization, we have like 3 to 5 people teams, so very small teams. And still, we achieve to do hundreds of deployments per week. So hundreds of changes to our website, despite we are 50 people and we need to coordinate this work, how these crazy people manage to do that. And every day, we have something around more than 50 A/B tests running in production. So it's not just about going to production and possibly not breaking stuff, but it's also embracing the idea of having continuously the idea of changing things and avoiding conflicts between multiple things running live. So this is kind of the cultural scale I'm talking about. I'm going to talk also a little bit about the technical scale. So we deploy this website, and 1 second later, we are going to have millions of requests per minute to what we just deployed. We have something I'm going to talk to you a little bit about, which is called microsites. So this is a way we decided to kind of slice these huge websites in multiple little parts. So, and underneath on the backend, we have hundreds of microservices that actually power up the data for rendering this view and this presentation. So what is a microsite, now that I'm mentioning it? So the microsite is a little experiment we did 3-4 years ago when we were still working on the same website. We were a lot of people already, but we used to deploy every month, not more than that. At some point, I joined the company, and I think they just switched to try to deploy every 2 weeks, which was like crazy. But if you think about that today, it's actually unacceptable for our business. So one thing we did was to try to slice our website into vertical parts. So what is a vertical part? Think about an e-commerce. We do software for restaurants. So for example, you go to a website and you search for a table you want to dine tonight. And more than likely, as soon as you find your table, you book it. Maybe you see the restaurant profile to see the photos of the food. And if you're happy, you click and you book. And tonight, you can go to dine there. So, and what we do is also we provide a lot of software to the restaurant, so your booking is instantly confirmed. So when we see about these two pages are what we call the on-page microsite, and this is like the restaurant profile microsite. They really look the same, and they have shared parts in terms of presentation, but there are 2 different teams that own this piece of code. And these are actually 2 different websites deployed independently. So in our world, what we call microsite is actually a little project, a little app that possibly has 1 page or 2, depending, and they are connected by domain logic. So if they are actually on the same domain, possibly they are in the same web application. For example, the search and the search results are the same microsites because they are kind of really well connected together. But we actually have something around 23 microsites that are a composition of our website. Some are more important, like the booking flow, where you book your table. And that's very nice because there are teams that need to know a lot about booking a table. They know about credit cards, they know about payments, and they are actually have a specific business goal. They have a product manager, and their goal is to make the booking experience secure, fast, and stable, for example, while a team like the search results have different business goals. For example, their goal is to actually have very quick search results, to have actually a lot of different search algorithms running in the page. So they need to know a lot about other kinds of problems. Same for the homepage. The homepage is presentation. They need to show a lot of things, experiment, so that people can actually try to look at the restaurants, etc., etc. So there are problems with this approach, as you can imagine. At the beginning, it seemed very easy. You said, oh, let's do that. It seems nice. At the beginning, we added this huge monolith as well on the front end. And when we built the first one, was search, if I remember, search microsite. One single team started deploying every day. They said, okay, we are going to do our own thing. We put a routing layer to actually override some specific page to go to the different microsite. And that team, at some point, started deploying changes every day to production. Instead of actually running 5 hours of UI tests just before deploying the whole thing, they could run 5 minutes of UI tests just around search. Their kind of boundaries were well defined, and together with the product manager, they were implementing changes every day. One interesting thing that happened culturally in our company at that point was a very important switch. We used to deploy by going to operations or infrastructure or sysadmins, how you used to call them 5 years ago, and ask them, can you deploy the whole thing? And this team said, we can't wait for that. We are going to deploy our own thing. We are going to monitor our own thing. We are going to do the whole thing by ourselves because we don't want to be blocked. And we want to deploy every day. We want to be super quick. 2 or 3 weeks later, this team was the best team ever. Everybody wanted to do the same thing. And immediately, a couple of other teams started, we started forming another couple of teams and working on similar ideas. But that didn't work well, because as soon as we started having multiple microsites, we started seeing a lot of repetition. So here I'm talking about the OpenComponents platform and these things here that you see in red. When you go from page 8 to page B, you can make this transition transparent, to completely hidden to the user, so the user couldn't realize that you are going from a website to another website from a presentation point of view. But if you will look at the HTML and hold the page, there was a lot of duplication. For example, the static assets or everything that was, for example, inside the header. The header seems like a little tiny piece of pixels there, but there is actually a lot of complexity. There is something that allows you to log in. There is something that allows you to explore or to search. And when we were going from breaking the monolith to multiple microsites, we were starting to have a lot of duplication, inconsistencies, etc., etc. So if you think about microsites as a pattern to slice a website into vertical parts, we wanted something to connect them again horizontally. So something that could solve the problems of shared components. So that's where I actually do a little live demo about what we built. And maybe not so many people here are into the front end, so I'm not going to go very deeper about explaining how it works, because I want to focus on the DevOps part of my talk. But I think it's useful if I just show you what I'm talking about. So this is a system that we call OpenComponents that we developed in-house. And this is something that challenges a lot of ideas that we were looking at that are part of the front end nowadays. When we were working on that, we said, you know, we have multiple microsites, maybe written in many languages. We wouldn't want just a components library that cares about just the presentation. We want a team that possibly owns the header to deploy the header every time they want. And this was challenging because today we have 23 microsites owned by 23 teams. It's nice because when you own your vertical, you say, I'm search, I can deploy every time. But if I own the header, do I need to ask 23 teams to actually deploy, to actually have my change? We actually wanted to solve that problem. And I'm going to show you a little bit how we did that. So we developed this tool, which is called OpenComponents, and you can access it on a CLI called OC. I'm going to do a very, very quick demo here. And the idea is you can have a folder of components. And I can create a new component. For example, I want to create DevOps Pro. I'm actually just going to call Moscow because it's a cool name. And here I can create a new component. This is going to use the internet, so possibly it's going to take a while. So just to summarize here, what we wanted was to create a tool that could empower people to actually be able to deploy single parts of the UI. So something that maybe you don't need when you are a small team of 10 people, but something that we really needed, because we had some people in the San Francisco time zone owning the header, and maybe someone in the London time zone owning a microsite. We wanted everybody to be independent, because when we have 50 people working on the same piece of software, you want actually independent teams, so that can be actually quick, they can iterate quicker to production, etc. So now that I created a component, I'm going to show you how to run this. So I run this component locally. I'm going to run a development machine here, and I see kind of a registry of components, including my Moscow component. And I'm going to show you how it looks like. So this is my Moscow component. It contains some metadata. For example, let me see if I can zoom a little bit. So it contains some metadata. For example, this is Moscow, and this is a test component. He has a very clear interface. For example, this component wants a name to be rendered. And this component then has a view that says, you know, I'm going to say, show up a little image, and then I'm going to say hello name. And then I'm going to have a little closure, which is called server.js. And this little thing basically accepts some parameters and allows my component to do HTTP requests to other services. Or, for example, to accept parameters from my interface. And the result is this one. I can go here, and I can show you in a better window maybe, that this is going to render. Let me show you a preview. Hello, and I can put something like name equals Matteo, and I can see hello Matteo. So this little component seems like a little piece of HTML. It seems like a very simple thing. Now I'm going to show you what I think is important here. So when I actually finish developing this, I can see my component here. I can say, you see, registry, add. And here I'm going to add a little registry that I set up for this demo, which I hope it works, because this is relying on the internet. Oh, let's retry. Am I connected? Yes. And then I can do a cpublish Moscow. So my component can have static assets. It has an interface. It has an auto-generated documentation. And as soon as we do that, I have an endpoint here. So if I open this and I go to this registry of components, I can see a bunch of test components that I published. But one interesting thing is I can see my Moscow test component. I can see that it's published. And now I have a URL that makes everybody that is aware about this URL able to consume this component and integrate it real time on his web app. So the idea really is each microsite, for example, needs to render the header. Instead of render the header and maybe require a library that on build time is going to build up all the static resources and is going to include it there, is actually on runtime going to make an API call to this service that is going to get the static HTML and is going to put it on the page. So every time the header or the Moscow component owner is going to need to deploy his own component, you can publish a new version of this component, and that's going to be automatically updated to all the microsites. So how to do that? I'm going to show you a couple of slides. And I don't want to go too much in detail because this is not a talk about OC specifically. But let me show you a couple of things. I showed you this and this. So now I can go to a page and I can set up the integration just like that. We created a little client-side library that allows you to have an OC component tag that maybe has different parameters. One interesting thing here is you can consume Each component is immutable, and we allow them to publish them, and you can consume them with a 1.x.x. This means that if the component owner publishes multiple components, you are going to consume the latest Meyer version of this component. It has a clear interface, in this case an optional parameter that is called name. And you can do also server-side rendering, so you can just make an HTTP call to this service, and you can see that there is kind of a version negotiation, and you have the HTML. If you are running a web server for your web app that is written in .NET or Node.js or Ruby, it doesn't care because you can just make an HTTP call here, and on the server side you can just place this HTML there. So this is a little bit how it works, and as you can see, there is kind of an API layer that allows to publish the components. There is underneath a lot of infrastructure, so the idea is as soon as you publish something, there is a lot of stuff that happen. All the static assets are actually minified and deployed to S3 and to a static CDN. There is something that executes the server.js closures. So if you know about serverless architecture, I'm not here to represent any vendor, but the server.js is a little bit like a Lambda, but is all self-hosted inside the registry. It basically allows to render the view model that then renders the view. And for example, nice things happened when we built this. For example, this is our restaurant profile. And one interesting thing that we have in this microsite is we have actually the photos and the reviews and the menus. Actually, in our company, we have a photos team. So that team owns the Photos API. They own actually all the optimizations we do on the photos, and they actually built this component for the restaurant profile. So despite the restaurant profile was something owned by another team, they were able to own their exact piece that was the restaurant photos component. This means that they started experimenting with a lot of things, and they didn't need to ask the restaurant profile team to redeploy that page every time they actually wanted to make changes and to reiterate. Same for the menus team. There are a lot of little heavy tests on the menus part, and they don't need to ask anyone to actually change anything on the code. There is an integration point of view, so step one, when they want to integrate the component the first time, but then step two, they can start reiterating multiple times. So the idea really is when we have a lot of teams, we don't want them to stop collaborating. We just want to optimize this collaboration. So if we can create a simple contract between the component creator and the component consumer, then as soon as this contract is actually well respected, we can actually avoid them to have unuseful interactions every time they need to review pull requests or to merge code bases, complex code bases, or to actually do the deployment, which is something we care about because we are in a DevOps conference. So it sounds a little bit complex, so I'm not going to go really into the details about how it works. And if you're thinking about a lot of challenges, yes, there are a lot of challenges on this, and I can talk a lot about how avoid conflicts, how we actually manage to overcome a lot of possible issues. But we actually started using this system for a lot of other things. For example, this is our emails, and we started creating little components for our emails too. So instead of having one single team that used to own all the emailing system, other teams started creating other components that could be part of the emails that we compose to our users. We also have external widgets, so all the restaurants that possibly are our clients have an external widget that allows to book a table via our platform, and we actually use the same thing for that. Every time we wanted to deploy our widget, now we could, because we didn't need the restaurant to re-update the integration code. We had just one little thing that looked like an iframe, but is not an iframe. So we got this for more than 2 years in production. We got like more than 200 components, and we have more than 11 teams that actually own components specifically. And we have something around now, this is like the 2 years average. The today average is higher than that. But in 2 years, we got something like more than 9 changes to production every day, just by people making changes to these components. So it is used, as I say, in multiple places, and we have millions of requests per day that actually go to these components infrastructure. So now that I gave you a little overview here, and I understand there is a lot here, I want to talk about something else. So I want to talk about continuous delivery and front end. So we spoke about continuous delivery, and this is a quote that I really like. You may have heard about that other times. This is by David Farley from the Continuous Delivery book. And you can see in software, when something is painful, the way to reduce the pain is to do it more frequently, not less. Very often, when we talk about continuous delivery, there is this concept that if you're afraid about deploying your code to production, you should probably deploy it to production more often. What we try to evangelize by creating a tool like OpenComponents was actually to make all the front-end people that were working on our infrastructure to overcome the fear of going to production. We wanted these people to get confident and to actually get used to the idea of getting to production every time they will do a little change in any component. Because every time they do now, they can spot issues immediately. If there are issues, they can actually make a better relationship with product managers and the business, and they can have a better impact to the company. So, summarizing, OpenComponents, we have simple HTTP contracts. So the idea really is to apply to the front end similar concept that we have in the microservices, but with services that are actually not really services, are possibly little interfaces for components. It's distributed by default, so we actually have, our business is not in Russia yet, but we are in many places in the world, in many continents, and as soon as you deploy one component in 1 second, you have this distributed everywhere. It's easy to test because one thing that you can do with OpenComponents is to actually look at how your component looks in a production page before deploying to production page, because we developed Chrome plugins to actually test this visually, but also other plugins to actually show how your change is going to look into production before putting in there, to test integration and stuff like that. And it's easy to change. So I want to talk about serverless. So serverless is something that is kind of a buzzword. Today, when we talk about serverless, we'll talk about those 2 or 3 famous vendors that are selling function as a service. But for me, serverless is much more than that. So serverless for me, when we talk about serverless architectures, it's something that is really close, in my opinion, to the DevOps world. So serverless is not about not caring about having a server or not caring about the infrastructure that is there. Serverless is about creating an infrastructure and tooling that is so powerful and that actually can empower people to think about what they want to build instead of actually and possibly overcome the fear of how to deploy that. So in OpenComponents, when you deploy your component, you don't care about if that component is going to run in and is going to need to have 100 requests per second or 1 million. That's something that my team does. So I own the OpenComponents platform, and I have monitoring about everything and alerting, and I know what the traffic trends are, and I know that other teams should care about building their front-end features instead of caring about that. So the idea is I developed this for them, and then we work together. One interesting thing is as soon as you publish a component in our infrastructure, you have automatic auto-generated dashboards in Graphite, for example, in Kibana and Elasticsearch. You have automatically monitoring for your team, so if your component is underperforming or if is having a lot of issues, you are going to have alerting immediately connected to you. So for me, serverless is a bit about that. It's about not having an infrastructure, not caring about it, but making it so easy to manage it that actually you can almost forget about that. You can just think about managing it instead of actually setting it up. That's just my 2 cents. And in my opinion, there are very good opportunities for the front-end world. We talk about serverless today for asynchronous functions, for microservices. In my opinion, we did a little contribution here for testing these patterns here. So for me, that's the most important thing. It's about ownership. So dev and ops working together on something. At the end of the day, we are talking about giving the teams the ownership that they need to be productive, and they do 100%. If they actually have ownership, more than likely they are going to work with product managers in a very fast-paced way. They are going to think about deploying their code to production every time they want and they need. And for me, this is like the most important thing about doing software engineering in 2017. And this is another concept that I really like. I didn't invent it. I found there are many talks online about this, but I think that a lot of talks, when we talk about software engineering today, focus about optimizing your software for maintainability. Why? Well, we know about that, right? You want to avoid repetition. You want to be sure that another team can understand the code base written by another team so that they actually can contribute. If a team doesn't exist anymore because someone leaves the company, optimize for maintainability means having good care. But perhaps one of the core concepts of microservices, and maybe microservices in the front end as well, is this idea that maybe if the code is so small that someone can really understand it. For example, if you're talking about a component to show the photos on a website, another team could actually just rebuild it if they need, and if they don't know how to approach that. So the idea of micro or nano services, maybe, just going buzzwords, maybe the idea is there is this idea of optimizing for destroyability that is not such a crazy thing. Keeping it so small, this doesn't mean not caring about quality, not writing any tests, quite the opposite. But the idea is having an infrastructure that allows you to forget about having something there and being in need of removing it or deprecating it. Just publish something new. And that's going to be staying there, but you don't care about it because that's another one's problem. And thank you. I hope I have enough time for questions because I really want to interact with you. Any?
have 1 minute.
Yes.
That's a small present for you
Oh,
from the DevOps conference.
Thank you.
Thank you for a great lecture.
Thank you.
Yeah, please go for Q&A.
Okay, thank you. Thanks. Anyone? Yes.
Now, listening for your specification. So, how do you manage really the problem of duplication? Because so many teams, so many components, and components really actually must be unique. I mean, they must have inside itself something unique, but it's not possible totally. How do you manage, how do you solve this problem?
So I'm going to repeat the question just for the camera. So how you manage the problem of having a lot of duplication. So having, I guess, my interpretation of the question is when we have this tool that makes it so easy for people to just create new stuff, can we actually have the risk of people maybe duplicating stuff, and also how inside the component we can actually have reusability of a shared part? Is this correct? This is the correct question, right? Yeah. So to be honest, there are many ways. So for example, when developing code for the front end, there are design patterns and there are practices. One thing that I didn't mention about OpenComponents, for example, is OpenComponents, you can see it as a kind of a delivery mechanism for HTML snippets. What is inside the HTML snippet, it's something that OpenComponents doesn't care at all. This means that, for example, in our company, at the moment we are actually using a lot of React. And the idea is you can use React as a library for actually having reusability. So for example, we have a components library, and we have like little items like buttons or checkboxes, similar to many other components library that we built in-house. And what we use OpenComponents for is actually just to have, and we have a shared repository for that. Everybody uses those libraries. But we use OpenComponents then to compose them and to release them. So the idea is OpenComponents is not in competition with other low-level front-end frameworks. It's just something that allows you to ship it. So this is a way to for example, avoid duplication inside the code base. So in this perspective, if a team, for example, creates this append actually in our company, a widget to do restaurant recommendations that has some components there and uses our recommendations API underneath to do that. and another team actually builds another component for an A/B test in another page that does similar things about, oh, you just booked this table in this restaurant, why don't you try this other restaurant, which is kind of similar. The idea is, I don't think it's too bad. Like, we have possibly two things that look similar, and maybe on the front end there is also another aspect, like when we bundle all together, we have the bundle size of all the static assets that can be reduced. Maybe in these cases you have a lot of little duplication of little files, but at the end of the day, that's not too bad. From an infrastructure point of view, for example, everything that OpenComponents serves is served by HTTP2. So for example, when you have a lot of components that have a lot of static files like CSS and scripts, they are actually all served down via a unique piped HTTP2 stream request. And we have obviously ways to do that. But at the end of the day, again, OpenComponents is not a way to avoid communication between teams and to make people not in need to collaborate anymore. It's just something that facilitates it a little bit. So we still make all of these people work together. We actually evangelize good practices, and many teams actually maintain shared libraries and stuff like that. So that's the idea. Did I answer? Cool. Yes.
You mentioned that you had quite a lot of challenges that you had to overcome in order to get this going. Could you please talk a little bit more about that?
Yeah. So I'm gonna repeat the question. So I mentioned that there are many challenges for a system like that. Maybe I can go a little bit expand on that. So a couple of things, really. For me, the challenges are two kinds. One is technical challenges, one is cultural challenges. When we talk about switching from deploying one piece of code base once every month to a piece of code that is deployed multiple times a day, it seems like, technically it seems amazing. Like, who wouldn't want that? Every engineer would want that. But in reality, culturally, this is very often almost impossible, because sometimes the composition, the way even the teams are actually composed and organized, it can represent a blocker for actually introducing technical innovations like that. For example, one of the things that I observed is when we actually started with doing the microsites, instead of having a unique team that used to do the front end, we actually started having little teams of 3 to 5 people. We used to have a team of 10, 15 people working on that consumer side, and then we switched to that. Now, building new teams, that requires time. It's something that maybe took 1 year to actually get new teams composing in a way, and when they did, they started saying, oh, we want to deploy our own thing. So then it followed up kind of a cultural shift, and that maybe took 1 year. 1 year later, they were trying to deploy everyone his own thing, and they were all deploying their own things in a bad ways and multiple ways. So then we said, okay, now we need a technical solution. So why don't we try to find a deployment mechanism that works for everybody? So a technical solution followed up. And when we started doing that, something cultural again happened as a consequence, which was like people now want to do A/B testing. People want to build this kind of apply these patterns that we actually did for microservice to the front end. So we started saying maybe we need a components tool like what we built. And when we did that, people started to, now there is actually a new thing in our company, which is what we call flex teams. We are actually going even further, and for important business initiatives, we are actually having these teams of 3, 5 people, sometimes to join up for 1 quarter, so that they can work on shared initiatives. And this is, again, another cultural consequence. So for me, the idea is it requires time. This is the biggest challenge. And sometimes it requires us a lot of courage, because when we talk about, for example, reorganizing the technical teams in a different way, sometimes you actually fight with the way the hierarchies are organized in your organization, and sometimes there is just organizations where they don't want to do that. I am lucky enough that we were in an organization where we were constantly challenging these things, and somehow we evolved our technical and cultural organization together. So for me, this is the biggest challenge. Sometimes when we wanted to do continuous delivery and continuous deployment 3 years ago, well, everybody was saying no, because we are a public company and there are problems. We need, for legal reasons, to actually follow some specific processes. And we couldn't challenge that. And 1 year later, we automated a lot of things to prove that we could actually do that, even if we were ready from day zero to do continuous deployments. So for me, the biggest challenges are always cultural. Sometimes you need time, and you need to educate people to what a new change really means, and sometimes these people just need to try it, because you can't explain it to people. You can't explain to people what does it mean to deploy 10 times a day if they deploy every month. They need to try it, and then they are going to realize that they can't go back anymore. So that's my idea. I don't know if I answered, but we can talk later. I can tell you a lot of other challenges if you want. Thanks. Do we have more time for questions?
Yes, definitely.
Another one? Yes.
If I understand correctly, you have to have some record about around these small companies, because you have some piece of code to manage all these components, and you have some templates to just make some layouts. And how does that work? How really from the top to small one?
Yeah. So I can explain. So when I did my little demo, for example, I created a little component, and as you can see, I already had like a little scaffolding, had an image, hello world. In our company, so in the OpenComponents world, for example, we developed this feature which is called templates. And what you can do every time you initialize a component is to initialize it in a specific template. For example, we have a specific template for React that automatically binds in all the React dependencies. It has CSS modules to actually be sure that your component has all the CSS encapsulated for that component. And this means that somehow, and then on the registry level, we have kind of a white list of templates that people can use to publish their component. So in this way, somehow we try to enforce a little bit some common practices. And more than likely, we actually reduce the overhead of setting up the whole thing all the time. So for example, you initialize a component, it already has all the part to transpile to ECMAScript 5 for the browser. It has all the part to connect the CSS, and you can just focus on creating that. And this includes, for example, also automatically connecting to other libraries that we developed. For example, we have a library for all the design tokens or for the base React components. So in theory, on the OC world, what we call components are just composition of little atoms. And on the server-side part of that component, you can use other libraries, and more than likely, you consume the data from other microservices. For example, in our company, we use now GraphQL a lot for actually doing data aggregation between our hundreds of microservices. And what we recommend to people when they design their component is just to create a GraphQL query to get the data that they want for that component to be rendered. So we have ways, and depending on the templates, you can do that. If you want to use OpenComponents, it's you can actually create your own templates. For example, because in your company you use AngularJS and you have a specific library for that, you can do that. One thing that I didn't mention just before leaving, because I think I need to, OpenComponents is also completely open sourced, and there are many companies that use it apart from my company. And if you like what you heard today, give us a start in GitHub and maybe get in touch with us, and we can talk about that for years, because we are very passionate about it. And I think I need to go.
Matteo, thank you very
Thanks.
much.